Find each value by referring to the graphs of the trig functions. We have cosecant of negative 540 degrees. Negative 540 degrees, you can find this in several ways. One method is to find a coterminal angle. Coterminal angles are always complete revolutions away from other coterminal angles. A complete revolution in degrees is 360 degrees. So I could add to this 360 degrees, which is going to give me negative 180 degrees as a coterminal angle. So I could find another coterminal angle if I didn't like that one, but I think that one's going to work nicely. That puts us right here. In that location, x we could say is negative 1, and y is 0, and r is positive 1. Cosecant, that's the reciprocal of sine. Sine is y over r, so therefore this is r over y, which is 1 over 0, which is undefined. So number 1 is undefined. Find each value by referring to the graphs of the trig functions. We have cosine of 300 degrees. 300 degrees is in quadrant 4. Since that's 300 degrees, it leaves the reference angle as being 60 degrees. 60 plus 300 is 360. That makes this a special right triangle. Opposite 30 we'll say is 1. That's x. Opposite 60 is whatever is opposite 30 times the square root of 3. We're in quadrant 4, we had to go down, so that's negative. That makes r 2. It's a special right triangle, 30, 60, 90. Therefore, cosine of 300 degrees, x over r, which is 1 over 2, or 1/2. Find each value by referring to the graphs of the trig functions. Tangent of 810 degrees. If I make one complete revolution in the positive direction, that's 360. If I make two revolutions, that's 720. 810 minus 720 is 90, which means the coterminal angle to this is 90 degrees. At 90 degrees, x we could say is 0, y we could say is 1, and r we could say is 1. Tangent of 810 degrees, that's y over x. That's 1 over 0, which is undefined. You're supposed to state the domain and range for this function. To do that, you need to know what this function looks like. Hopefully you have that memorized. It should look something like this. Where there are vertical asymptotes here on the y-axis, and then here at 180 degrees, and another one here at 360 degrees. Should have that memorized by now. So what's the domain? Well, it looks like the domain is all real numbers, except for every place there's a vertical asymptote. So one way to write this would be to say all reals except where the vertical asymptotes are, and those vertical asymptotes are every 180 degrees k, where k is any integer. Where do I get this 180 degrees k? Well, really I would get it from saying, where is my first vertical asymptote? And first can be determined as any vertical asymptote. If I start here at 0, I would say my first one is at 0 degrees. And how far apart are they? Each vertical asymptote is 180 degrees away from the next one. So the distance between each one is 180. K, where K is any integer. 0 plus anything is that anything. That's why I just wrote 180 degrees K. What is the range? That's your numbers going up and down. Notice there is no part of the graph in this region. No curve hits that part. So our range is everything but that part. So when we do our range, we're going to go from smallest to biggest, which is how we do our domain as well. So our domain is going to start at negative infinity. It's going to go until it gets to negative 1. It includes it. This location right here is y value is negative 1. We're going to unite that with going from 1 to infinity, because the bottom of these parabolas is 1 and it goes up forever. Take the domain and range for cosine. This also you should have memorized. Cosine looks like this. Keeps going on forever and ever. It's a periodic function. Goes as high as 1, goes as low as negative 1. Notice as you go left to right, you can trace over this whole thing forever, never lifting up your finger. So the domain, the x values we can put in is everything, which we could call all reals. We could say it goes from negative infinity to infinity. Those are both the same thing. The range, well, it goes as low as negative 1 and then high as 1. Never does it go above 1, never does it go below negative 1. So from smallest to biggest, we get negative 1 to 1. Please note, it includes negative 1, so we use a bracket. It includes positive 1, we use a bracket. Infinity and negative infinity are not numbers, so they're never included. It's parentheses. You should have this memorized as well. Cotangent. Cotangent looks like this. That's the basic curve, and that's repeated over and over and over forever. Every so often, there's a vertical asymptote. These vertical asymptotes are hitting at 0, 180, 360, etc. So the domain here is everything except for the vertical asymptotes. So we could say the domain is all reals except every place there's a vertical asymptote. In this case, that's happening every 180 degrees K, where K is any integer. The range, this graph goes up and down forever without interruption. So the range is all real numbers, or we could say, using interval notation, negative infinity to infinity. State the amplitude, period, phase shift, and vertical displacement for each function. Amplitude, that's the absolute value of A. In this case, A is 2. The absolute value of 2 is 2. Find the period and phase shift, that requires work in most cases. To find the vertical displacement, that's the number that you're adding or subtracting outside of your angle. In that case, it's 6. To find the period, the new period, and the phase shift, take the angle you're given, which is theta, put it in the middle of a compound inequality, on the left where a period of sine starts, on the right where it ends. Then get theta by itself. In this case, theta is already by itself. So the new period is the same as the parents. And the phase shift, there is no phase shift, because this graph has not moved left to right. State the amplitude, period, phase shift, and vertical displacement for each function. Amplitude is the absolute value of A. The absolute value of 10 is 10. Vertical displacement requires no work. That's the number you're adding or subtracting outside of the angle. It's negative 8. New period and phase shift do require some work. Take the angle you're given, put it in the center of a compound inequality. On the left, put where the period of sine begins, which you can pick anything you want. Usually we pick 0. Depending on what you picked at the beginning, over here on the right, you need to pick where that period is going to end. Well, if I'm starting at 0, the period of the parent graph is going to end at 360 degrees. So once again, where the parent's period starts, where the parent's period ends. Trying to get theta by itself, I'm going to multiply each term by 3 to get rid of this dividing by 3. So I do times 3 times 0, and I get 0. 1/3 times 3 is 1. 900 times 3, pardon me, 300 times 3, 900. And then 360 times 3, that's 1,800. Then to get theta by itself completely, I'm going to add a 900 to the left, the middle, and the right. So I get 900 degrees less than or equal to theta, which is less than or equal to 1,980 degrees. Phase shift, we were starting at 0, now we're starting at 900. So the phase shift is 900 degrees. New period. You take the end minus the beginning of your period. So that's 1980 minus 900, which is going to be 1080, 1,800. That's the new period. So you have the amplitude, period, phase shift, and vertical displacement for each function. The word amplitude is a special term reserved for sine and cosine. This problem's tangent. Therefore, there's no amplitude. Vertical displacement, phase shift, and new period are found the same way they're found for sine and cosine. Vertical displacement's always simple. It's the number you're adding or subtracting outside the angle. It's -4. The new period and phase shift you find by taking the angle you're given. In this case, the angle we're given is 2 times theta minus 180 degrees. Put it in the middle of a compound inequality, on the left where a period of tangent may start, and on the right where that period would end. Tangent's parent period is 180 degrees. Now we want to get theta by itself. We could do lots of things here to do that. Most people would find it easiest to first distribute this 2. It's not what I would do, but I'm guessing it's what you would do. So I'm going to do it to make you happy. Then we could divide each term by 2. We could add 360 to the left, the middle, and the right. Either of those things next. I'm going to divide by 2 so I get smaller numbers. 0 divided by 2 is 0. 2 theta divided by 2 is theta. 360 divided by 2 is 180. 180 divided by 2 is 90. Finally, adding 180 degrees to the left, the middle, and the right, I get the following, which means my phase shift is 180 degrees. I was starting at 0, but now I'm starting at 180. And I made a calculation error here. This is not 90. It's 90 plus 180, which is 270. To find the new period, take the end of your period minus the beginning. So that's 270 degrees minus 180 degrees, which is 90. No amplitude, new period is 90 degrees, phase shift is 180, and vertical displacement is -4. Write an equation of the sine function with each amplitude, period, phase shift, and vertical displacement. Well, the amplitude and the vertical displacement are fairly straightforward. The period and phase shift, factoring those in, is not so easy. So here's what we do. We write a compound inequality where we have theta in the middle. Over here on the left, we put the phase shift, pi over 2. Over here on the right, we put the phase shift plus the period, which is 4 pi. The goal then is to manipulate this equation so that it's in the form of where the parent's period would normally start and where it would normally end. As we're dealing with radians, we would want this to be 0 on the left and 2 pi on the right, because the period for the parent for sine is 2 pi, or 360 degrees. I'm going to first subtract pi over 2 from the left, the middle, and the right, so I can get this left side to be 0. Pi over 2 minus pi over 2 is 0. Theta minus pi over 2 are not like terms, so we'll write them separately. Pi over 2 minus pi over 2 plus 4 pi is 4 pi. Now we're trying to get this to be 2 pi. Some problems are easier than others, so I always do them like they're difficult. I have to take 4 pi and multiply it by some number k so that it equals 2 pi. To get k by itself, divide both sides by 4 pi. Pi's cancel, and you get 1/2. You need to multiply every term by 1/2. So I get 0 times 1/2 is 0. Theta times 1/2 is 1/2 theta. Pi over 2 times 1/2 is pi over 4. 4 pi times 1/2 is 2 pi. Once you've successfully made the left side and the right side a normal beginning and end of the parent's period, then you are finished. Was to write an equation of the sine function. Y equals, it's always plus or minus the amplitude, in this case the amplitude is 4, times sine, it's sine because this problem says write the sine function, followed by our angle, 1/2 theta minus pi over 4. Our angle would be the center of the compound inequality, and we add or subtract our vertical displacement. Our vertical displacement was 5, so that makes this hot mess our equation. Write an equation of the sine function with each amplitude, period, phase shift, and vertical displacement. Period and phase shift, using those, requires quite a bit of work. We take theta and put it in the center of a compound inequality. On the left, we put the phase shift. On the right, we put the phase shift plus the new period. Then we manipulate the inequality so that we get 0 on the left and 360 on the right. 0 and 360 because that's the normal beginning and end of the parent graph's period. If we had 90 degrees to the left, to the middle, and to the right, we get the following. Now we're trying to get 225 degrees to be 360, which is not going to be simple. So to figure out what we have to multiply that by, 225 times some times something to equal 360. If we divide both sides by 225, we're going to get k is 360 over 225. Hopefully that reduces. It does reduce. It reduces to 8/5. So that means we need to multiply each of these terms by 8/5. So 0 times 8/5 is 0. Theta times 8/5 is 8/5 theta. 90 times 8/5. Let me do some side work because I don't know what that is. You can divide both 5, that shouldn't be degrees, simple here. You can divide both 5 and 90 by 5. 5 goes into itself once, goes into 90 18 times. 18 times 8, using a calculator, is 144. So 144 degrees. Less than or equal to 225 times 8/5. Better be 360, otherwise our k was wrong. Answer, y equals plus or minus your amplitude times sine of our angle plus or minus your vertical displacement. Our vertical displacement's a -3, so we say -3. This angle we got from the center of this compound inequality. Write each equation in the form of an inverse relation. Well, the inverse of sine is sine inverse. If we do that to the left side, and we do that to the right side, on the right side, the inverse relations cancel, So we get sine inverse of 0.23 equals theta. You do not have to show this work. I'm just explaining it to you. You could have also written this answer as arc sine of 0.23 equals theta. Sine inverse and arc sine are synonyms. Write each equation in the form of an inverse relation. We have cosine of beta is 1. The inverse of cosine is cosine inverse. If we apply that to both sides, on the left, the cosine and cosine inverse cancel. On the right, we get cosine of negative 1. Pardon me, cosine of positive 1. So we get beta as cosine of 1. We could also write this as beta equals arc cosine of 1. You don't need both. You need one or the other. This work that you see here is optional, just explaining how it works. Evaluate each expression without using a calculator. Calculators are for noobs. Assume all angles are in quadrant 1. Well, this first one is ridiculously simple. Secant and cosine are inverse relations. Scratch that, not inverse relations. They're reciprocals. So whatever cosine of an angle is, secant of that same angle is that same fraction reciprocated. So with no work, the answer to this is 1. If you'd like to see some work, let me show you some work. Cosine inverse of 1. Cosine is x over r. For x to be 1 and r to be 1, it's got to be over yonder. The directions say assume angles are in quadrant 1. Technically this is not in quadrant 1. It's on the x-axis. I apologize for that. So, in this location, it's 0 degrees. Therefore, we could say that secant of cosine inverse of 1 is equal to secant of 0 degrees. What is secant of 0 degrees? Well, it's the reciprocal of x over r is r over x, which is 1. Either way, you get 1. Another way to look at this whole problem is the following. This is an equivalent statement to what this problem asks. If cosine of theta equals 1, find secant of theta. This is the same thing as this, if that helps. I apologize for the simplicity of this question. Cotangent of arctangent of 4/5. Cotangent and tangent are reciprocals. Therefore, with no work, this answer is 5/4. If you'd like to see some work, we're in quadrant 1, arctangent of 4/5. Tangent is y over x. So let's say this is theta. So from this picture, we could say that arctangent of 4/5 is theta, because that's the angle that makes that triangle. Well, what's cotangent of theta? That's x over y. That's 5/4. With work or without work, this is 5/4. Evaluate each expression without using a calculator. Assume all angles are in quadrant 1. So, doing this in parts, we get sine of tangent inverse of 1 plus cosine of cosine inverse of 0.5, which I'd rather write 0.5 as a fraction, 1 over 2. So what is tangent inverse of 1? Well, tangent inverse of 1, that would be this angle right here, theta. Tangent is y over x. Our fraction 1 as a fraction is 1 over 1. That makes this a special right triangle, 1, 1, square root of 2, which makes theta 45 degrees. Technically, we don't even have to know that to finish this. So that makes this sine of 45 degrees, because tangent inverse of 1 and 45 degrees are equivalent. Plus cosine, cosine inverse. Inverse relations. They cancel each other out, which makes this 1/2. Sine of 45 degrees, look at our picture. Sine of 45 degrees, the opposite leg, 1 over the hypotenuse, square root of 2. Rationalize your denominator, you get square root of 2 over 2 plus 1/2, which is square root of 2 plus 1 over 2. When you add two fractions, you add the tops, but you don't add the bottoms. There's to graph each function and its parent function. Well, to graph this little guy, I need to know what a is, which is the absolute value of 2 in this case, which is 2. I'm sorry, that's not true. Please strike that from the record. A is just 2. Amplitude is the absolute value of that. A is whatever the leading coefficient is. Doesn't matter if it's negative or positive, the answer goes here. Could be tangent, cotangent, could be any function. We need to know what the phase shift is. We need to know what the new period is. We need to know what the vertical displacement is. Vertical displacement here is 1. That's simple. To find the phase shift in the new period, take the angle you're given, put it in the center of a compound inequality where the parent would normally start and end for a complete period. Then, get x by itself. We could subtract 45 from both sides, the left, middle, and the right, or divide each term by 3 first. I'm going to divide by 3 first so I get smaller numbers. 0 divided by 3 is 0. 3x divided by 3 is x. 45 divided by 3 is 15. 360 divided by 3 is 120. Subtracting 15 from the left, from the middle, and from the right, I get the following. Makes my phase shift negative 15 degrees. I was starting at 0, now I'm starting at negative 15. My new period, I take the end of my period minus the beginning. Subtracting a negative is like adding a positive. I get a period of 120 degrees. I take that information and I plug that in here. My new period is 120. My parents was 360. My phase shift was negative 15, which makes this simplify to x prime is 1/3 x minus 15 degrees. My y prime is my a, which is 2 times y, and then plus my vertical displacement of 1. This column here is for the parent. So for my parent graph, since I'm using degrees, I'm going to go 0, 90, 180, 270, and 360. For sine, it goes 0, 1, 0, negative 1, and 0. To find my new values, I plug the x values into this new equation. So I'm going to have 1/3 times 0 minus 15, which is just going to be 15 degrees. Next I'm going to have 1/3 of 90 degrees minus 15, which is going to be 30 minus 15. The first one was negative 15, which is 15 degrees. Then I'm going to have 1/3 of 180 minus 15. That's 60 minus 15, which is 45. Then I'm going to have 1/3 of 270, which is going to be 90, minus 15, which is 75. And then finally, I'm going to have 1/3 of 360, minus 15, which is 120, minus 15, which is 205. my new y values, I take my original one, multiply it by 2, and then add 1. 0 times 2 is 0. 0 plus 1 is 1. Next one is 2 times 1 plus 1, which is going to be 2 plus 1, which is 3. Next one is 2 times 0 plus 1, which is 1. Next one is 2 times negative 1 plus 1, which is negative 2 plus 1, which is negative 1. And then finally, 2 times 0 plus 1, which is 1. I'm going to graph the parent with these ordered pairs, then I'm going to graph this new graph with these ordered pairs. Since I have to graph 15 degrees, I'm going to count every 4 spaces. Well, how am I going to do this? I don't have a lot of space here. So let's get a little bit crazy. And let's count every 3 spaces. Let's count every space as 30. So we get 30, 60, 90. 30, 60, 90. 30, 60, 90. 30, 60, 90. My parent graph, sine, is going to look like the following. It's like this. I got my points messed up. I like this. I got these points here. Ignore those first points that I drew. Probably could have spaced this out better. But if every spot is 30, then every half a spot is 15. So I got points at 15, at negative 15 degrees 1. So that's to the left 15 and up 1, which should be about here. I have a point at positive 15, 3, which should be about here. On my y-axis, I'm counting every 1 is 1. 1, 2, 3, 4, 5, 6. Then I have a dot at 45, 1. So if this is 30 and this is 60, 45 is halfway between. And I have a spot at 75, negative 1. And then 105, 1 again. So my graph is going to look like this. This is the red one, and then the black one is the parent. Supposed to graph the function and its parent function. To do this successfully, I need to know what A is, which is the lead coefficient, which is a 1. I need to know what my phase shift is, which requires some work. I need to know what my new period is, which requires some work. I need to know what my vertical displacement is, which requires no work. That's the number you're adding or subtracting on the outside of the angle, which is negative 2. To find my phase shift to new period, I take the angle I'm given, 4x minus 90 degrees, put it in the center of a compound inequality. On the left, where the parent of cotangent begins, and where one period ends on the right. I then want to get x by itself. I am going to add 90 degrees to the left, to the middle, and to the right of this compound inequality. I'm then going to divide the left, middle, and the right by 4. 90 divided by 4 is going to be half of 90 and then half again. Half of 90 is 45. Half of that is 22.5. Dividing 270 by 4. 270 divided by 2 is 135. 135 divided by 2 is 67.5. My phase shift then, I was starting at 0, and now I'm starting at 22.5. It's 22.5 degrees. To get my new period, I take the end of my period minus the beginning. So that's 67.5 minus 22.5, which is 45 degrees. Using this information, I should be able to make a table and figure out where my points are going to be. X and Y here are for the parent graph. Cotangent's period is 180, so I would count, go from 0, 45, 90, 135 degrees, and then 180. Cotangent of 0 degrees. 0 degrees is on the positive x-axis. There, x is 1 and y is 0. 1 divided by 0 is undefined. Cotangent of 45 degrees is 1 over 1, which is 1. Cotangent of 90 degrees would be 0 over 1, which is 0. And cotangent of 135 would be 1 over negative 1. And then cotangent of 180 is going to be undefined again because we have 1 divided by 0. So that's my parent. For this graph, y equals cotangent 4x minus 90 degrees minus 2. We take the new period, which is 45 degrees, divided by the parent's period, which is 180 degrees, times x. Add in your phase shift, which was 22.5 degrees. And this simplifies to x prime is 1/4 of the original x value plus 22.5 degrees. To find my new y value, I take a, which is 1, times y, add in my vertical displacement of -2. So y prime is y minus 2. So to get my first x prime value, I'm going to take 1/4 of 0 and then add 22.5 degrees to it. 0 times 1/4 is 0. 0 plus 22.5 is 22.5 degrees. Then I have 1/4 of 45 degrees. That's half of 45, which is 22.5, and then half of that again, which would be 11.25. If you add that to 22.5 degrees, that would give us 33.75. Hopefully I'm adding right. Next, we're going to take 1/4 of 90 degrees, which is 22.5. So I get 22.5 plus 22.5. That's going to give me 45 degrees. Then we're going to take 1/4 of 135 plus 22.5. It's 33.75. I had to use the calculator for that. Plus 22.5. That's 56.25. I'm really stretching my table out here a bit. Then we got 1/4 of 180 plus 22.5. 1/4 of 180 is half of 180 twice. That's 45 plus 22.5. 67.5 degrees. So there I have my angles. Now I have to figure out my y values. The undefines are going to just be undefined. It requires no work. My 1, I'm going to subtract 2 from it and get negative 2. My 0, I'm going to subtract 2 from it and get negative 2, which means I just added wrong. This 1 minus 2 is negative 1. I have negative 1 minus 2, which is negative 3. So my parent is these ordered pairs and some not pairs but undefined. And then my new graph are these points. So let's see if we can graph this. The important things to be able to graph here is the 22.5 undefined, 45 degrees negative 2, and 67.5 and undefined. These intermediate points that you see here is just to make sure that your curve is curving in the right direction. So, if I'm going to count by 22.5s, I'm going to make every 2 spaces 45 degrees. It means 22.5 is halfway between each of those. So, graphing my parent, which I think I did in red, had a vertical asymptote on the y-axis, had a vertical asymptote at 180 degrees, and my curve was positive 1 at 45, so it looks something like this. Let's say this is 1. And at 135 was negative 1, so something like this. So that is my parent. Now this new graph that I'm graphing, it has a vertical asymptote at 22.5, that would be here. Has another vertical asymptote at 67.5, which is halfway between 45 and 90. And then at 45, there's a dot at negative 2, which would be right here. At 33.75, I had a dot at negative 1. At 56.25, I think it was, I had a point at negative 3, which just confirms how this graph is curving, which is from left to right, it goes high to low. So there's my black graph. Over here's my red graph. That's finished. This has nothing to do with this problem, but I just got a phone call. Here's one of the delightful things you have to look forward to if you decide to get a college education. Once you graduate from your college or university, you will receive phone calls from that university 3-4 times a year for the rest of your life, asking you to find it in your heart to give more money to that university. That's right. Once you've received your degree that you paid for it, they're going to call you for the rest of your life and ask you if you'd like to donate more money to the university. Boy, is that annoying. I apologize. Graph each function and its parent function. Y equals negative 2 sine of 2x minus 180 degrees plus 3. To do this, boys and girls, we have to know what A is. We have to know what VD is. We have to know what the phase shift is. We have to know what the new period is. As always, A is simple. It's the leading coefficient. Vertical displacement is simple. It's what's being added or subtracted to the outside of the function. Phase shift and period, not so easy. Take the angle you're given, 2x minus 180 degrees, put it in the middle of a compound inequality, where the left side and the right side combined make the starting and ending point of a complete period of the parent function sine, which in this case 0 to 360 degrees. Trying to get x by itself, we could add 180 to the left, the middle, and the right, then divide by 2, or we could divide each term by 2 and then add 180 to the left, the middle, and the right. Well, if there's 180 left, which there won't be. I'm going to divide first, because to me that makes the numbers simpler. I'm going to divide 0 by 2 and get 0. 2x divided by 2 and get x. 180 degrees divided by 2 is 90. 360 divided by 2 is 180. I'm then going to add 90 degrees to the left, the middle, and the right, giving us a phase shift of 90 degrees. We're starting at 0, now we're starting at 90, giving us a new period of 270 minus 90, which is 180 degrees. Once we have those facts, we can then make our table. X prime is the new period, which was 180 degrees, divided by the parent's period of 360 times x. Add in your phase shift of 90 degrees. This simplifies to x prime is 1/2 of x plus 90 degrees. To find your new y value, you multiply your original y value times a, which is -2, add in your vertical displacement. The points for my parent graph. Sine, this period is 360, so we're going to go from 0 to 360 in equal intervals of 90 degrees. Hope that didn't just mess everything up, and it probably did. Oh well, it happens. Sine of 0 degrees is 1. No, it isn't. It's 0. Nice looking 0. Sine of 90 degrees is 1. Sine of 180 is 0. Sine of 270 is -1. Sine of 360 degrees is 0. X prime. Take half of x and then add 90. So in this first one, we're going to take half of 0 plus 90, which is going to be 90. This next one, we take half of 90 plus 90. It's going to be 45 plus 90, which is 135 degrees. Then we got half of 180 plus 90, which is 90 plus 90, which is 180. Then we get half of 270 degrees plus 90, which is 135 plus 90, which is 225. And then we have half of 360 plus 90, which is 180 plus 90, which is 270. How exciting. Find our new y values. We multiply them by -2 and then add 3. So we have -2 times 0 plus 3, which is 3. Next we have -2 times 1 plus 3, which is -2 plus 3, which is 1. Next we have -2 times 0 plus 3, which is 3. Next we have -2 times -1 plus 3, which is 2 plus 3, which is 5. And then finally we have -2 times 0 plus 3, which is 3. Now I have to graph this. And I made the mistake. I always have you use different colors. This here would all be in black. 1,000 pardons. So graphing this, Our y values went up as high as 5, so I'm going to go up vertically, up by 1s. And we went clear to, well, we went from 0 to 360. Stars went on the x-axis, and we had to go by 45s. So let's just go every 4 spaces is 90. Give us plenty of room. Parent graph. You had a point at 0, 0, 91, 180, 0, 270, negative 1, 360, 0. So your curve looks a little something like this. That would be y equals sine of x. Now graphing this bad boy right here, we have a point at 90 degrees 3. We have a point at 135, 1. We have a point at 183. We have a point at 225, 5. Then we have a point at 273. If you were doing the whole midline thing, your midline would be here. And your graph would go as high as 2 above and as low as 2 below. You don't have to do that blue part, but if it helps, you should do it. Connecting my points with some nice curves, I get concave up and then concave down. So that's what your graph would look like. Last problem, need to know what A is, what the vertical displacement is. A is -2. It's the leading coefficient. Vertical displacement is 1. It's what you're adding on the outside of the function. What your phase shift is, and what your new period is. Take the angle you're given, put it in the center of a compound inequality where the bread in this compound inequality sandwich is the beginning and end of a complete period of the parent function. Solving this equation, I'm going to add 45 to the left, to the middle, and to the right. Then I'm going to multiply each term by 2. Gives me a phase shift of 90 degrees and a new period of if I take 9, 10 minus 90, you know what, I multiplied wrong. 405 times 2 is 810. 810 minus 90 is 720, which makes more sense. So my new period, 720 degrees. So with this information in my table, I'm going to be able to graph this successfully. X prime is the new period, which is 720 degrees over the parent's period, which is 360 degrees, times x, plus your phase shift of 90. This simplifies the x prime is twice the original x value, and then translated to the right 90 degrees. Y prime is going to be a, which is -2, times y, plus the vertical displacement of 0, plus 1, I should say. My parent graph, which is cosine of x, goes 0 degrees, 90, 180. Hope I didn't fudge that up again. Think I might have. Be sad if it happens. Can't tell until post-production if I just made everything out of whack. We'll find out. Then, cosine of 0 degrees is 1, 90 is 0, 180 is negative 1, 270 is 0, 360 is 1. So, I'm going to take each of my x values here, plug them into this equation for x to figure out what my new x value is. So I got 2 times 0 plus 90, which is 90. And I have 2 times 90 degrees plus 90, which is 180 plus 90, which is 270 degrees. Then I have 2 times 180 degrees plus 90 degrees, which is 360 plus 90, which is 450. Then we have 2 times 270 degrees plus 90, which is 540 plus 90, which is 630. And then 2 times 360 plus 90, which is 720, plus 90, which is 810. My new y values, I'm multiplying by negative 2, the original ones, and add 1 to it. So I have 2 times 1 plus 1, which is 2 plus 1, which is 3. I'm sorry, that's wrong. It's negative 2 times 1, which is negative 2 plus 1, which is negative 1. Next we have negative 2 times 0 plus 1, which is 1. And we have negative 2 times negative 1 plus 1, which is 2 plus 1, which is 3. Then we have negative 2 times 0 plus 1, which is 1. Then we have negative 2 times 1 plus 1, which is negative 2 plus 1, which is negative 1. Then we graph. So I'm going to count by every 2 spaces is 90. Should be 540. Sorry about that. 630, 720, 810. Parent graph had a point at 0, 1, 90, 0, 180, negative 1, 270, 0, 360, 1. So it looks like that. Let me draw a little bit more of this. Alright, so then our new graph, we had points at 90 degrees, negative 1, 271, 453, 631, and at 810 at negative 1. So our curve looks like this, looks like this, looks like this. In black is y equals negative 2 cosine of the angle x over 2 minus 45 degrees plus 1. And in red was the parent graph y equals cosine of x. And scene.